Okay, welcome everybody. Glad you could make it. It's the last afternoon of Devoxx France. My name is Stephan Janssen. For the people who do not know me, I'm guilty of founding Devoxx 23 years ago. It was named Java Polis back then. And I've also founded like Devoxx for Kids. And my new baby is basically Devoxx Genie, which is a tool, a coding assistant written in Java. And so what I want to talk about in the next 45 minutes is really AI-augmented programming using modern Java. Now, I use the first letters of every word where it ends up in AAP. And I'm from Belgium. I speak Dutch, Flemish, and AAP means monkey. And the reason why I wanted to use that acronym monkey is that these days, well, in the past, we were using Stack Overflow to copy and paste without thinking. Now we're using LLMs and just copy the code, or even, the LLM just inserts the code, and we don't even look at it, because as long as it works and our unit tests are not broken, we just continue, right? So it's a bit of a monkey business, because I would not recommend doing it like that. What I normally do is that I create like a Git branch, a feature branch. I'll let the LLM do whatever it wants to do, but then at least before I push it, I will look at the code, what it has generated, if it's still okay. So please, please try to stay in control of the code, right? That's definitely an important one. I spoke yesterday. Who was at my agentic talk? So there was a few people there. Okay, so this is a different talk. It's two parts. I want to first give a quick introduction because a lot of people do not really know, like what is inference, what are the players, etc. So that's the first part. But my second part is mainly about how we can use Java to do LLM inference. And there's not that many talks on this yet, but it's a very interesting one, because if you're a Java developer, you just want to continue building and working in Java. I don't want to just do Python all the time, right? Because that's a bit of the problem, is that the innovation today in LLMs is happening in Python, and Java is basically catching up. And so this is what I want to talk about and give you. I have quite a few demos as well, so that should be fun. So if I look at how I develop these days, every day, I use Claude Sonnet 3.7 from Anthropic. Who uses that as well, just out of interest? Not that many. Okay, who uses code assistants using LLM? Okay, the people who are not raising their hands, make sure you do, because they will be more productive than you. That's at least my experience, right? The one I use every day is Claude Sonnet 3.7, because that's the one which is the best one for coding up to now. But there are many new players. Every week there's a new version coming out. Like this week, beginning of this week, OpenAI announced GPT 4.1. The interesting one of 4.1 is that it has a 1 million token window context. So that's very interesting, because you can put the full project in the window context and then start chatting about it. But it's still not as smart as Claude Sonnet 3.7. The other one is, of course, Google. Yesterday evening, they released Google Gemini 2.5 Flash, which is a lot cheaper than the 2.5 Pro, which they announced a couple of weeks ago. And you already see the trend. I'm talking in weeks, not months or years. This is going so fast that every week there are new announcements and new ground-shaking things, like the agent development kit, which was announced last week. It's a fast-paced, moving target. It's really unbelievable. Then, of course, I'm very, very proud that at least we have a European solution, which is Mistral. It's French-based. Most likely the founders are already living in Silicon Valley, unfortunately. But hey, we do have a European voice, which is great. Same thing for Hugging Face. Hugging Face is French, so félicitations, c'est vraiment parfait. Because we do need this European movement, especially if we have a white, or what is it now, an orange monkey on the other side. We need to have a bit of backlash, right? But then, of course, we also have the Chinese, which is with DeepSeek. I mean, DeepSeek is very, very interesting. DeepSeek version 3 and the reasoning model is unbelievable. They have a free version, and if you're scared about privacy, they also have it hosted in US data centers. But let's be honest, if privacy is a concern, do not use any of those. Because you will read the small letters, they will use your prompts, they will use your code, and they will train on it. Don't be naive, that's going to happen, right? So if you do work in government or you work at military or intellectual property is really important, you have to use local models or on-premise installations of these models. So that's also possible. I saw a talk yesterday about vibe testing, where Orange used on-premise implementations of these LLMs. That's also possible. But I'm just one developer at home. I don't have that luxury. So the alternative is use local inference engines. The one you can really use, which I used almost daily, is Ollama. It's free, it's open source, and it runs on Windows, Linux, and Mac. And what you're starting to see is that the local model providers, they are starting to use also the Apple Silicon Metal GPUs that are available. There's an initiative from Apple called MLX, and MLX is really an LLM inference using the Apple Silicon. So that's very interesting. So you should try to focus on those and those models which are fine-tuned for MLX if you're on Mac. If you're on Windows, it's NVIDIA, and then you need to focus on those. I think it was 1 month ago, Docker even announced support for LLM inference. But what they're basically doing, they're using Llama CPP or Llama C++. And Llama C++ has been driving the innovation of these local models. It's like the Swiss Army knife. They're all using that. It's like when you were doing video editing, the tool to use video editing, it is FFmpeg. Right? This was like the Swiss Army knife to do video editing and so on. Well, for LLM inference, it's Llama CPP. It's open source, beautiful code. It's a guy from Bucharest, if I'm not mistaken. Hungary, excuse me. And Docker is basically using that. So you can have it enabled in the Docker desktop, and when you then talk to Docker, it will basically use Llama CPP for you. Now, if you have an inference engine, you still need a model. You still need a large language model. So if you're running locally, the ones that I'm using are these listed here on this slide. Might take a picture. I'm not using Llama 4 because they faked a bit the benchmarks. They actually looked at the benchmarks and trained the model on the benchmarks, so they were cheating, so to speak. But like Llama 3.1 is a very interesting one to use. And you have different flavors. The flavors are the number of parameters that it has included. So you have an 8 billion version, 70 billion version, and a 405 billion version. I had to negotiate with my wife because I bought a new MacBook and I was really negotiating with her how much memory I could buy, right? Because the more memory you have, the beauty of Macs is that you have unified memory. So it's basically, if you have 128 gigs, it can use the full 128 gigs. And so like 70 billion works on my machine. It gets very hot, but it does work. The 405, it does not work. So you need to have alternative solutions for that, which I will talk later on in the slide deck. Now, you can actually, there are benchmarks. This is an interesting one, which I look a lot of, or use a lot. It's called lifebench.ai. And they will actually compare the different models and actually tell you which models are really good for coding. Because I use LLMs for coding. That's really my main focus. And just yesterday, I think OpenAI released O3 High, O3 Medium, and it already immediately is reflected that it seems that O3 High is one of the better models out there. Gemini 2.5 is very good. It not only has a very big window context, but it's really not expensive. It's very, very cheap compared to, for example, Claude Sonnet 3.7. But Claude Sonnet 3.7 is still, I think, my workhorse. It's a really good one. But this changes on a daily basis almost. But yeah, keep that in mind. Go to that one. So I was telling you, I organize Devoxx Belgium. I go to other Devoxxes as a speaker or as a tourist where I can just enjoy the conference. In Belgium, I just run around like a headless chicken from one fire to the other. And you prepare it for 9 months, and then when the event is there, you can't really enjoy it yourself. But the beauty of organizing a conference like Devoxx Belgium is that you get a view of what's hot and what's not within the Java developer ecosystem. And this is like a cloud tag view of the talks, I think it was 2 years ago. And there you could already see that large language models, generative AI, and even for Devoxx France, I think the AI track had the most proposals. They had 1,000 proposals in total, and I think it was about 150 talks in the AI track alone, so like 15% almost. So it's clear the excitement, also for me, is there. But I call this, if you were in my talk yesterday, I call this the quantum superposition state. It's both exciting and frightening at the same time, right? Because these models are doing things where you go like, what the hell? Wow, really surprised me. But as a senior developer, if you use it right, you can really use it as a great tool to be more productive, seriously. And so if you look at like 2 years ago, and this is still the introduction, I'll go a bit faster. Basically, you have an application, you talk to an LLM. This was 2 years ago, right? 1 year ago, well, and then how does it work? Well, you have a system instruction. That's very important. You set the scene like, hey, you're a Java expert assistant, which will help you code with Spring Boot and Angular, for example. That's important to say that. That's your system instruction. Then you have a user prompt, maybe with some extra context, which could be your project. If it's a small project and it fits the window context, you just include it. And then it could have memory, because if you have a conversation going, you want to know the previous questions and answers, and it stays in that conversation, right? So this is how we did it last year. And what was invented last year was also this tooling possibility. You could say, hey, and this is like the hello world, they use get weather. So they say, hey, I have this method here called get weather. And then you say, what's the weather going to be in Paris tomorrow? The LLM doesn't know about tomorrow, so it will say, but I have a method which is named getWeather. So it will return and say, well, call this method getWeather, give me the response, you give it back to the LLM, and the LLM will give a nice answer, tomorrow it's going to be shiny 18 degrees in Paris. Right? And that's the tooling support, right? But this was 2024, that's how you did it last year. Yeah. How do you do it now? It's a bit different, but before we go in there, there's 2 players. I assume you're all developers. Who's all using Java? I think that's a stupid question. The majority, yeah, of course. So you have basically 2 options. You have LangChain4j, which, by the way, was announced at Devoxx Belgium 2 years ago. So I'm very proud about that. But it had an enormous traction now. It's really becoming a very important player. The main contributor now works for Red Hat, so Red Hat is basically guiding that a bit. And the alternative is Spring AI. So those are the 2 players that, if you want to do LLM in Java, those are your 2 options, to be honest. You can do it like pure REST and just use the REST calls, but once you start switching different models, different providers, new features, before you know it, you're building LangChain4j. So just use these frameworks, they're really good. And they're very comparable. They look almost identical. I mean, if you look at this example, it's a bit small, but hopefully you can read it. You need to create a chat model. You then create a request to the chat client. I'm selecting a certain Ollama model. So this is local, using a local Ollama provider. I'm providing the weather tool, and then I call it, and I get the content. And this weather tool there, well, there you would implement, some kind of service going to some weather API or whatever. And if you look at the Spring version, they look the same. They're just copying each other. Because basically, a lot of them, like LangChain, started with Lombok, so it uses the builder pattern. So they're basically doing builders here, which is good for developers. We can very easily switch if you want. They're basically copying and pasting each other. If you look at 2025, or I would say November 2024, Anthropic announced MCP, Model Context Protocol. If you want to start doing tool implementations and so on, this is how you need to implement it. You need to follow MCP. Why? Well, Anthropic announced MCP, but OpenAI has just mentioned 2 weeks ago that they will also support MCP. And last week at Google Cloud Next, Google also announced that they will support MCP. So if you have those 3 players supporting MCP, it's by default the standard. The cool thing is that these MCPs implementations can be done in different languages. So you could have a Java implementation as an MPC service. You could have one in Python, in Rust, whatever. And it can be installed remotely. It doesn't have to be on the same machine. It can, using the standard I/O, but it can also use just server-side events and have it remotely. The only problem is that the S in MCP stands for security. You get the joke? There's no S. There's no security. This is, I call this the cowboys and Indian Western type of situation. This is so brand new, so early, that you have to be very careful with this stuff because it has no authentication, it can do really strange things, but it's moving in the right direction. The new specification will have authentication. The Spring team is working on that because the reference implementation in Java, so Anthropic has a Python version, but they also have a Java version, Anthropic, which is the ones responsible for Claude. The Java version is developed by the Spring team. So that's really great. They know what they're doing and it's going to evolve. Cool. So that was my introduction. Still got 30 minutes for the cool stuff, which is the modern Java inference. So what I want to talk about is that there's a new wave coming for us Java developers, which is very exciting, very, very exciting. And basically, this is the executive summary. If you look at what's been happening within the Java language, and you look at LLMs, the time where it spends the most is in matrix multiplications. It's basically doing matrix multiplications backwards and forwards. And there we have in Panama called Vector API version 9, which actually does that in a very fast and performant way. And that's obviously, what we need to use if we want to do inference. So there is this, and it's already version 9, so they've really been iterating over and over and over to make it very performant. But it's almost as it runs in pure assembly. It's really very performant. Where it's lagging a bit behind is GPU support. So I don't know if you follow these projects, but Babylon is a very promising project. And there, what they want to do is do matrix multiplications not on the CPU, but on the GPU. And if we can do that on the GPU, then we're rock solid, because then if it's in Java, it will then just be supported on all the different platforms. It doesn't matter if I'm on Apple Silicon or Linux or Windows. So that's the holy grail. That's the reason why it's also in red. They're not there yet. All the other stuff, like foreign functions and memory, that's also a very important one, because this will also be used to move the weights around in memory and so on. This is very important. That's all in place. But GPU, not yet. However, there is actually, I believe they're based in the UK university. I can't remember the university, but there is an initiative called Tornado VM. And Tornado VM is a Java library. It's open source. And they do GPU support, but it's more like an R&D exploration type of initiative. What I'm hoping to see is that they will introduce abstraction layers, so we just don't care about what GPU chips they're using, but we as developers, we just work on a higher level. Right? Now, oops, I pressed on the wrong button. There's actually 2 projects that already support these libraries, and it's a bit experimental actually. And this is called jlama and llama3.java. Those are the 2 ones. Now is a good time to take a picture, because that's like your mental set. This is basically what I want to talk about the next 26 minutes. So the good thing about organizing a conference like Devoxx is that I know what's going on. I try to be a bit of, follow the trends, etc. I invite these people and come to talk about it. So Jake Luciani, he actually spoke about this last October at Devoxx Belgium, where he showed jlama. And you can find jlama here at github.com tjake/jlama. And the QR code is the link to his talk. I looked at his code, because I was first building my own vector database-ish type of thing. I was playing around. And then I looked at his code and I went like, oh, I'm not worthy. I mean, his code is so beautifully developed. Seriously, you should just look at it. Beautifully done. He works for data stacks. And IBM actually bought DataStax a couple of months ago. So this means IBM, Red Hat is part of IBM. So you're going to start seeing jlama appear most likely in LangChain4j as well, because it's all part of the IBM Red Hat environment. And so what he did is that it's a fully developed Java inference engine, completely in Java, but he's still switching to some C parts where we don't yet have everything covered in Java. And so what you're able to do is actually start jlama, say, hey, enable the REST API, and use this model. So it's a simple model, 1 billion just for playing around. And if it's not yet on your local machine, auto-download it. So let's have a look and see how that in action. Here it is. So if I'm not mistaken, there it is. So I've just run the command. Because the REST API was a parameter, it will start Spring Boot, so we have a REST interface. And then here, I've built my own Devoxx Genie, which is like a Java plugin for IntelliJ to play with, because a lot of these code assistance plugins, they're too lazy. It takes too long for them to update to the latest features. And if I have my own plugin, I can immediately do it, right? So what I've done here is that I have configured a custom open URL. It goes to localhost 8080. And so if I can now say, hey, tell a joke, it will talk to this one, and it will hopefully give me a joke back. So what you've now seen, this was full Java. No Python has been used here. Now, but what's really nice is that not only is the plugin developed in Java using LangChain4j, but I talked to a local Java Spring Boot app, and I could actually debug all the way till where the matrices are multiplied with each other. So I can now finally debug and understand how do these models work? What do they do behind? I mean, I'm like a little boy, right? If you get a car, you want to open it and see inside what's in it. Well, now you can do that, right? So I think that's interesting. And it's fully Java, so I could even include this model, which it was using a local model, I could include it in the plugin, and all of a sudden, it's just in my Java stack, all Java. I can have some new opportunities, some new things I could actually develop by having it all in Java. I find that exciting. Am I the only one, or? I think that's cool. And I mean, this was not possible a year ago, so it's all moving nicely in the same direction. So that's that one. I just showed you Devoxx Genie. That's a marketing slide, but it's basically my open source project. It's free. It's full in Java. I accept pull requests. It supports MCP debugging as well. We've got like 17,000 downloads already, so people really like it. I'm really proud. And what's very important, it runs on all the IDEs of JetBrains. So if you do PyCharm or WebStorm or CLion, you can still use that plugin. But anyway, it's just a hobby project. So I already demoed that. The other one, inference possibility, is from this interesting persons. Alina was here yesterday. I don't know if she's still here. I think she already left to the next conference. But Alfonso Pettersson and Alina, they both work for the Graal VM team in Switzerland, Zurich, if I'm not mistaken. And Alfonso did a demo last year about llama3.java. This is the project. Should have a look at it, because what's very interesting is that he built a Java inference engine completely in Java in one class. Wow. So he was inspired by, I always pronounce his name wrong, Carpacci, who used to be the AI assistant of Tesla and then left. And he did that in C++. He basically migrated it to Java, which is pretty awesome. And I actually had the pleasure to co-present with him at Vox Day CERN. Like CERN, if you're a Catholic, you want to go to Lourdes. But if you're a scientist, you want to go to CERN, right? Once in your life. Well, we actually have Vox Days there, and we did the talk together about this. And so he basically did a full implementation of Llama 3 in a single file, no dependencies. There it is. And it supports the GPT-generated unified format, so you do need to have a GGUF model, and there's plenty of them out there. He supports Float 16. quantized versions of 8 and 4 float. So, you know, it's great, it's very interesting, but what excites me more is that he works for the GraalVM team. So what does that mean is that they create native code with the GraalVM, right? So since this week, so I'm talking weeks, right? They released Java 25 early access, 17 Graal, and this finally allows me to actually create a native executable on Mac, Windows, and Linux. Only since this week, well, only since, where's the date? April 16th, so a couple of days ago, I can create a native application of this llama 3 Java file and just run it on my Apple Silicon, which is pretty exciting. So let me show you that. So if you go here and you go to llama, here it is. So this is the, let me get rid of this. This is the, let me just scroll down. So it's 2,545 lines of Java code, but this includes documentation, right? So it's maybe 2,000 lines of Java code, which is pretty cool. And then what I can do, I can actually do, if I believe, a make native. There it goes. And now it's creating a native version for my Macintosh based on that Java file. You can see it's building here. And so it's supporting FFM, so foreign function memory. It supports the vector API. And after a couple of minutes, I will have a native executable. And the crazy thing is, I didn't do that, but you could even include already the parameters in the native application. So when you start it, it already has the weights in the application. Here, I'm loading it on demand because I want to maybe switch between different implementations. So there I have it. And so if I'm not mistaken, I can just do, let me go to this one. Where am I? Oh, no, this is the one. Yeah, okay. So I do, sorry, it's a bit low, but it's llama 3. So that's the executable that I've just created. I select the model, and then I give it a prompt, what is the capital of France, right? So if I execute that one, it has still a few warnings, but basically, paf, that's it. No, it loaded the model at 83 milliseconds. The model can be preloaded, so you could already remove that. And then for answering that specific question, you know, I have like 12 tokens per second. So, you know, he did a demo at Voxay CERN, and it was faster than Llama CPP. So it's faster than native C++ code, because it's basically assembly now. Yeah. I mean, the applause goes to these guys at GraalVM team, right? I'm just demoing it, but I'm like, look, I get goosebumps because I get excited about this stuff. I don't understand why Oracle doesn't promote this more. I mean, come on. This is fast inference locally in Java, and they are not promoting it. So it's like, I don't know. Cool, but that's great for us. Now, the problem is, I don't have a REST interface. So I remembered I was flying to another Devoxx event. In the plane, I basically wrapped it with Spring Boot, so I have a REST interface in front of that. But then they announced this native one, so I went like, well, maybe I should just call the native application. So that's what I did yesterday evening in my hotel room. Yeah, sorry, I like doing these things. So what I did is that I created a Spring Boot wrapper. But to be very honest, I didn't create it. I just did vibe coding, right? I just give the source code to Claude, and it just produces the code for me, right? So what it does here, if I'm not mistaken, so I can just run this one here. Let me just stop this. That one is stopped, that's fine. So I've just started it, so it's a Spring Boot wrapper around the native app. And now I can say, tell a joke in my Devoxx Genie, and it's talking to that one. This will not work. Why? Because I I've opened up the Java file and it's including it also in the chat. And so the window context is very small, so it can't handle that. So let me do that again and see if I can make it work. Get rid of that, do a new one. Okay, tell a joke. There it is. So it took a bit longer. Why? Because I'm actually passing some, in Devoxx Genie, it tries to include in system instructions and so on, so that's why it took a bit longer. But basically, it did understand that I wanted to ask a question or a joke, and it basically answered it. So I've wrapped it with Spring Boot and just called to it. So this opens up real opportunities, seriously. If you have a Java enterprise or just a Java application, you want to include the model and you want to do inference in Java and then even compile it to native code, this is, since this week, this was not possible last week, since this week, you finally can do that. Great. This opens up really new opportunities. Cool. All right, so what's next? Well, one of the questions I get is like, yeah, but I have like DeepSeek, for example, the big model. I would like to run it locally at home. How can I do that? Well, there's something, everybody probably knows database sharding, right? So you shard over multiple databases. Well, there is some concept called LLM sharding. So LLMs, they have multiple layers, and what they are doing is that they're sharding the layers on different machines. So if you have like a certain model which has 40 layers, you can have the first 10 layers on this machine, then the 20 or the other 10 layers on that machine, and so on. And then you need a coordinator to actually move that around. And as a result, you can actually then run large language models, not only on-premise, but at home. Right? And so I knew about this, so I invited the guys who actually developed a solution called EXO. Mohamed, he's one of the founders. He actually developed a Python version, but a Python version with Apple Silicon focus. So he was focusing on the Apple machines. And what you can do, this is a screenshot from my home. I've got 3 machines at home, and they are interconnected. So I think they use some kind of UDP to discover each other. And then each one of them says, okay, well, I have this type of memory, this type of CPU on Apple. And then together, we aggregate it, so I have about 70 teraflops of GPU power for running a bigger model. Now, this is very interesting. The QR code goes to the talk from this person. It's open source, but it's developed in Python, right? That's a bit the unfortunate thing. But they do some crazy things. They're running the DeepSeek version. I think it was 670 billion parameters. They're running it on 2 Mac Studios. They interconnect it using Thunderbolt 5, and they're able to actually have quite a bit of good response. The problem is, 1 studio costs 12,000 euros. Now, I don't know with the tariffs if it's now 30,000 or not, but I think it's 12,000 each. So for 24,000, or let's say 25,000 euros, you can run DeepSeek on 2 machines next to your computer. You can ask your boss. I mean, I asked my wife, she said like, no way, you're not getting this. I said, but honey, for Valentine, no, you're not, no way. So, okay, you can do the other one, is that, okay, well, I'll get all my Mac Minis and just glue them all together and start it. That's an alternative. And this is a real picture of somebody who has a lot of money, or he's a boss of a big company, and he basically glued them all together and had 123 teraflops, so he could run this big model. Now, I must say, with all honesty, or without joking around, there's also something called VLLM. Sorry. That's really what the big players are using. The problem with VLLM is that it's only for NVIDIA-type-based machines. It's not for Apple Silicon. So I'm really trying to follow that, because they are starting to they're starting initiatives to also start focusing on Apple Silicon. And so VLLM is like the Ferrari of LLM sharding, right? Now, the good thing is there is also a Java version. Jake, again, he actually developed sharding using full Java. So if you don't like Python, you can do this in Java. And he does sharding by layer, by attention heads, or combined. You have to ask ChatGPT what that means, because for me that's Chinese. But it works, and he, yeah, I mean, he's a genius in my opinion, because the code looks beautiful and the feature he has, there's a reason why IBM probably bought them, not only for Jake, but A. Cool. Still 9 minutes, so what are the other LLM opportunities? So running it locally is definitely a possibility. There are options, I gave you those. Have a look at that. GPU support, so the thing that I said, like jlama is faster than llama CPP, this was not yet running on GPU. So once we have GPU support, Java is going to be king, right? Which is, that's important. I mean, it's a big community, it's important. But we need to wait for Babylon, right? So that's important. There's an article here which they already done, Tornado support, but I believe it was for Llama 2, not for Llama 3. So I'm hoping they will catch up. And there's lots of other interesting things going on. Probably you've heard about Microsoft BitNet. So what they're doing there is they're using 1, 0, and -1 instead of floats. So as a result, if you're only using 1, -1, and 0, you can have very big large language model basically compressed, because you don't need all these long floats anymore. And what they have noticed is that if the model has a lot of parameters, the intellect is still, the response you get is still intellectually acceptable. If it's a very small model, it produces garbage. But if you have a model of like 600 billion parameters, and you do bitnets, you actually it still has a use. And Microsoft is actually driving this. Another interesting one, there's so many. I mean, I could have 100 slides of interesting research papers, etc. But these are just the ones I'm like following. One is meta layer skip. So what they're doing is that, okay, if a model has 40 layers, 40, they say, oh, let's try and see if we skip layer 2, 4, 6, 8, and see if we are still getting sensible information. And it seems it's like with a human brain, if somebody has a certain portion of his brain removed, he or she might still be able to speak, etc. So by doing that, you reduce the model, and they are still getting intellectual or valid responses. The other one is very interesting, byte latent transformer. There, they are using words, not tokens. So I don't know if you follow this, but the people are saying like, oh, it's artificial general intelligence, right? And then they say, how many R's are there in strawberry? Yeah? And because of tokens, they actually combine words together, so it doesn't really know the letters. It only knows a group of letters. So it often answers, oh, there's only 2 R's, but there's 3. Well, with byte latent, it does it on byte level. It doesn't use tokens, which is a group of letters. It just uses 1 character or 1 byte for tokenizing it. So as a result, you actually get more intelligent conversations if you want to know how many letters are in a word. That's the other question if you want, but there's other use cases. I'm paraphrasing here, of course. So what's next? Well, this is a bit of a repeat from yesterday, but for the people who were not there, what you need to focus on today is the following, which is this one. For me, Devoxx Belgium 2025 will be about this. This is where the excitement is. If you want to do agentic programming, if you want to do agentic workflows, last week, so this is really fresh from the press, last week Google announced agent-to-agent communication, so how do agents communicate with each other, and it's over HTTP using JSON RPC, so very similar to what MCP is already doing. But they also introduced Agent Development Kit, which is the one in the middle, and this overlaps a bit with MCP, so it's not very clear how that's going to work. But there's a really interesting movement there, and I'm very excited. Why? Well, the first version is in Python, but they have promised on stage that they will also have a Java version, and we're expecting this end of May. this year. So we have a full version of all of this doing agentic workflows. Let me quickly show you the code. So this is how it looks. It's a very abstract, it's a new abstraction layer on top of MCP, where you basically define an agent, then the sub-agents, then the agent itself has certain tools. These could be MCP tools as well. And it's Google, so they by default support, of course, Gemini, but you can also use the Light LLM to support other models like OpenAI or Claude or whatever. And like I said, they're going to support Java. Let me quickly demo this, because this is really interesting. So I developed over the weekend. They announced it last week, so this weekend we had a rainy weekend in Belgium, so what do you do? So I developed a coding assistant, so I have ADK Web here, ADK Web. This basically triggers the agent. It creates a local host, and then I can go to localhost 8000, and I have like a debug view of this. So now I can say like coding assistant, voila. And because I have already my agents, etc., I can say like, how do you develop a hello world REST endpoint, or develop a hello REST endpoint using Spring Boot and Maven build. Something like that. A typo doesn't matter. And so now it's talking to the agent. I can actually see which agents they're calling and what tools they have available, and it will start communicating with each other if all goes well, and basically start to execute. And it's like an agent orchestration. It will try to get the job done based on the agents that I've provided. Wow. I mean, I built this in 2 hours, and it's a full coding assistant, and it also has access to my GitHub account. So I could actually have, these are the tools for, I could actually then say, create now the GitHub repo and push that code to GitHub. Or I could even say, no, go to this GitHub project and evaluate the code and tell me what's wrong and fix it. And it just goes backwards and forwards, and it does. I mean, this is like the Terminator for coders. I can build this in 2 hours, so it's like the question is, how can I still make a valid business and make money if everybody can make this in 2 hours? I don't know, right? So we need to be creative and add other new layers, and it's like I said, superposition states, exciting and frightening at the same time. So I try to focus on the positive. These are very interesting times. We can be much more productive. We can do crazy things, which last week was not possible. So be creative, produce, and have fun. And I thank you for your attention. So we still have 2 minutes. If you have a question, maybe let's do one. And then I'm still here for a while, so I'll be in the hallway if you want to talk to me. But any questions? Yes? Well, hold on. Maybe he's going to give you the microphone. That way it might be better.
So yeah, thank you for the presentation. It's very interesting. Regarding the slide where you were talking about the fact that the Java implementation was faster than C++.
Yes.
So it's a bit. I mean, it's really interesting because C++ basically compiles also to
yes.
Native. I mean, the lowest level possible code. And how is that? What does makes this magic? I mean, because in the past I used to write some benchmarks to rewrite NASA benchmarks from Fortran to Java. We published a paper, and our reviewers said,
I need to stop you there because I don't have the answer.
Just I know. Yeah. Just to say you that when you have such statement, I mean, the community will basically don't accept it until you prove.
Well, so hold on. So the link I gave you to the talk at Fox Day CERN, he demonstrated it, and the demo is in the stream. So let me, because I mean, I'm not a bullshitter, right? I want to see what's going on and what happens really. So If you go to this talk here, you will see the demonstration.
Okay.
And Alfonso, knows what happens. I'm not as smart as him, so he knows what they are doing. But it was faster than Llama CPP. So,
it's
I'm like...
and you even said that it's not using GPU, right?
No.
So it means it uses CPU only.
Yes.
Probably it's faster. I don't know why.
You need to do some research.
Yeah.
Okay.
So probably there are some AVX 5 stuff instruction set used inside. But anyway.
But thank you for it's a valid question, and you have to be critical for sure. Any other questions? Still 7 seconds. Well, anyway, thank you. Have a great afternoon.